Okay, back into lesson 8.5. We're going to do the second part of 8.5, which is isosceles trapezoids. Okay, so I'm going to go ahead and put 8.5 up here at the top. And once again, we will start with our definition. So we already know what a trapezoid is. It's a quadrilateral with exactly one set of parallel sides, and those are called the bases. Okay, and if you remember from one of my drawings in the other video, okay, right here, the other two sides, the non-parallel sides, are called legs. Okay, that's going to be an important term as we define isosceles trapezoid. Now, we've seen this term before, isosceles, when we talked about triangles. An isosceles triangle was a triangle with at least two congruent sides. Remember, it could have three, okay, but it was at least two. Excuse me. Isosceles trapezoid is the same idea. An isosceles trapezoid has at least two congruent sides. Okay, so an isosceles trapezoid definition: a trapezoid with at least two congruent sides, and the congruent sides are the legs. Okay, remember, the bases cannot be congruent, because if one set of sides is both parallel, remember the bases are the parallel sides, if one set of sides is both parallel and congruent, then we have a parallelogram, which in our book, remember, parallelograms and trapezoids are different, and most geometry books you see will be that way. Although, like I said in the other video, there is some disagreement on that. Okay. Now, you could have three congruent sides. Right? You could have the two legs congruent, and they could be congruent to one of the bases. You cannot have four congruent sides, because remember, four congruent sides, equilateral, is a rhombus, and a rhombus has to be a parallelogram. So this could be two or it could be three, but you're not going to have exactly four. You're not going to have none. Okay, trapezoid would have no congruent sides. All right, so let's draw a couple, maybe two examples here of isosceles trapezoids. So the first one would look something like this. Okay, so we got our bases that are parallel, all right, and then our legs are congruent. Okay, so there's one example. All right, hold on one second, and I'll be right back. Hopefully you got that example written down while I was gone. Sorry about that. All right, another example. Okay, and I'm going to show you what might happen. Remember, our parallel sides can go up and down instead. Okay, so here we'll put some parallel marks. I'm going to put two to just kind of show they're different than the first ones. And then same thing, I'll do two here. Now what you can get, and I don't know if I drew it very well here, if it looks like it to you, but you could get this side and this side also congruent to this side. So you could have three congruent sides here like this. Okay, but like I said before, you cannot have all four sides congruent. Okay, so there's our couple of our examples. All right, let's go to sides. All right, so let's look at our things here. Opposite sides are parallel. Well, that's part of the definition of any trapezoid. Okay, two sets or one set. Remember, it was one set, so that's A1 by definition. A1. All right, let's look at letter B. Opposite sides are congruent. Yeah, that's what we just drew. Two sets? No, it's just one set. Remember, it's the legs. Okay, so B1. It's also by definition. That was part of the definition of isosceles trapezoid. Okay, let's look at C. All sides are congruent. Nope. Remember, all sides are congruent makes it a rhombus, and all rhombuses are parallelograms. Okay, consecutive sides are congruent. Well, we could have this side right here congruent to this side over here, and we could have this side congruent to this side, so we could have two sets of consecutive congruent sides, but we don't have to. Remember, the only things we're going to write down here are things that have to be true. Okay, so that's it. Let's go down to angles. Opposite angles are congruent. No. Okay, it wasn't true for normal looking trapezoids. I don't want to use the word regular, because regular has a very special meaning in geometry, but typical trapezoids like this one. Okay, and you can see here that that angle right there is not going to be congruent to that angle down there. The opposite angles are not going to be congruent. Okay, what about consecutive angles or supplementary? Yeah, we already talked about that back over here. B2. By what theorem? The consecutive interior angle theorem. So same reason. B2 by theorem. Which theorem? The consecutive interior angle theorem. Okay. All right, what about C? All angles are congruent. No. Equiangular has to be a rectangle. Rectangles have to have 4 right angles. All right, we can't have 4 right angles here. If we got all equal angles, it's going to be a rectangle. Rectangles have to be parallelograms, so that's not going to work. Okay, next one. Consecutive angles are congruent, 4 sets or 2 sets. This is actually true. It's 2 sets, and I'm going to try to prove it to you here. Okay, and this is actually, I believe, in your book. Let me see where it says. If a trapezoid is isosceles, then each pair of base angles is congruent. Okay, that's theorem 8.14. All right, it also has a converse, so and theorem 8.15. So really, they could have put it into one theorem with an if and only if, but they chose not to for whatever reason. The converse says if a trapezoid has a pair of congruent base angles, then it has to be isosceles. Okay, so let me try to prove theorem 8.14 to you. Okay, so sometimes this proof is a little difficult, but let me see if I can do it and have you understand it. All right, so I'm going to start with just kind of proving that regular version. So we are told that we have a trapezoid, so these are parallel, and we are told that these are congruent. Okay, so what we want to try to prove is that the base angles are congruent. Now, what do we mean by base angles? All right, so base angles, remember this was the base, okay, right here, and this was the other base. The base angles are angles that touch the same base. Okay, so this angle right here and this angle over here are base angles. Okay, this one here and this one here. This up here and this up here also touch the same base. Okay, so we want these angles to also be congruent. So these two are congruent, and then down here these two are congruent. All right, so trying to prove that. All right, let's see. What happens is we know, let me put some letters in here so I can explain this hopefully a little better using the letters. Okay, thinking back to a previous postulate we had, we know that if we have a line, so let's say AD is our line, and we have a point B that is not on that line, then there is exactly one line through B that would be parallel to AD. We know it exists. It has to exist. So I'm going to draw that right through here. And I'm going to call the point down here where it would meet. I'm just going to call it E. Okay, I'm going to draw it kind of as a dotted line. So we know some line here has to exist. We could use our compass and construct it if we wanted to, but we know it exists. I'm just going to draw it in here and say, hey, it's got to be there somewhere. Let's just call that spot E. Now, we know then, we just said it's got to be parallel. So I'm going to draw this in here with my marks for parallel. Now AD is not parallel to BC, it's parallel to BE. Okay. Alright, so now, what do we know about this shape, ABED? Well, we know it's a parallelogram, right? So we're kind of ignoring this for right now over here. So we're just looking at this shape here. ABED is a parallelogram. Okay, well, what are some things we know about parallelograms? We know that opposite sides are congruent, right? That was one of our theorems. So that means AD has to be congruent to BE. Well, AD's got one mark on it, so BE needs to have one mark on it. Okay, well, hold on. By definition of isosceles trapezoid, AD was congruent to BC. So now we can use a transitive property and we can skip this, okay? So we knew AD was congruent to BC, definition of isosceles trapezoid. Theorem for parallelograms, AD is congruent to BE. So skipping AD, we can say that BC is congruent to BE, okay? Now, let's look at this. Well, what happens if I only look at this now? Okay, just this shape. Triangle BEC. Well, what kind of triangle is that? Well, that's an isosceles triangle, right? Okay, isosceles triangles have 2 equal sides, and then remember how we draw these arrows down into the corners? We know that this angle has to be congruent to this angle. Okay, so we're applying a couple old theorems here, some we haven't looked at in a while. Okay, well, that's not quite what we were trying to get to. Remember, we were trying to prove that this angle here was congruent to this angle way over here. All right, let's go back to looking at the parallelogram. Okay, so let's cover this up now for a little while. All right, so what do we got here? All right, let's extend this out a little bit. Let's extend this out. Let's extend this out. What do you notice about this angle and that angle? Especially if we kind of cover up the top a little bit too. Okay, we got some parallel lines. Okay, parallel lines. We got a transversal that's above the transversal and off to the right. This is above the transversal and off to the right. So these are corresponding angles. So these angles are congruent because of the corresponding angles postulate. Okay. Well, wait, now we use that transitive property again. If this angle was congruent to this angle, isosceles triangles, the base angles theorem for isosceles triangles, and this angle is congruent to that angle by corresponding angles postulate, I can skip this angle and say this angle, angle D, is congruent to angle C. So now let's look back at what that original trapezoid looked like again before I started drawing all this extra stuff in it. Remember when we first started drawing it, it looked like this. A, B, that top part was parallel to this bottom part, C, D, and these were congruent. Okay? And what we just proved is that angle C was congruent to angle D. Okay, that's one set of base angles that are congruent. Now, what do we know about these two angles? We know they're supplementary, right? Supplementary means they add to equal 180. Well, what do we know about these angles? They're supplementary. They add to equal 180. So if I take a number, whatever this number is, maybe it's 80, or maybe it's 70, I don't really know, but it's some number, and I subtract it from 180, that's going to give me this answer. Well, over here, I'm taking the same exact degrees as this one, and I'm subtracting it from 180. Well, it should give me the same exact answer up here as it does over here, unless we subtract wrong. But if we subtract wrong, then we did it wrong. So if we subtract correctly, taking 180 from these, subtracting this number, whatever it is, we should get equal answers up here. So that means this and this have to be congruent. That's actually from the congruent supplements theorem, if you remember that theorem. It's one we don't use a whole lot. Congruent supplements theorem said if two angles are supplementary to the same angle, it's not quite what we're doing here, or two congruent angles. So these two angles up here are supplementary to two angles down here that are congruent to each other. Then these two angles have to be congruent to each other. So what we end up with is this angle is congruent to that angle. That's one set of consecutive congruent angles. And we have another set of consecutive congruent angles up here. That's what D2 was saying. Okay, if we look back at this, D2. All right, and over here, if we look at D2, consecutive angles are congruent. Two sets, okay? So, I want you to look at this one more time. It's important for you to understand. The base angles are congruent. These are called base angles. Are congruent. And that's here and here. Okay? Also up here, base angles are congruent. Here and here. Okay? Well, what about over here? If you want to call them the leg angles, that's fine. They don't really technically have a name, but I'll call them the leg angles. And they are supplementary. Okay, here and here. Those two angles are supplementary. And we can do the same thing over on this side. The leg angles are, and I'm going to run out of room, so I'm just going to abbreviate, are supplementary here and here. Okay? So let's look at all of that at the same time. Okay? No, wrong way. Okay, so we have two sets of congruent angles, here and here, and here and here. We have two sets of supplementary angles, here and here. Okay, make sure you keep straight which is which. Okay, so that's theorem 8.14, and its converse is theorem 8.15. The converse works like this. If I have a trapezoid, that doesn't look very isosceles, sorry, but if I have a trapezoid and I tell you that these angles are congruent, then you tell me it's isosceles. This is congruent to that, these two sides, the legs. Remember, the bases aren't going to be congruent. Okay, so in our previous version, if I tell you this, then you tell me the angles are congruent. Okay, that's theorem 8.14. This is theorem 8.15. If I tell you this, the angles are congruent, then you tell me the legs are congruent. Okay, so it works both ways. It could be written as a single theorem if they did if and only if, but our book chose to put it into two different versions. Okay. All right. One more thing. Got to look at that diagonals box. Okay. So let's bring this back. Diagonals. Remember, it was empty over here, so there's nothing we can transfer over here. But there is going to be something that's true. Do they bisect each other? No, because if the diagonals bisect each other, both of them, then it has to be a parallelogram. Okay. Congruent to each other. Let's take a look at that one. All right, so let's get a sheet of paper out. Let's take a look at that one and see if we can prove that. That actually is going to work. Okay, so here we go. Draw my isosceles trapezoid. Remember, it's got to have these congruent legs and these parallel bases. And we know that we have this and this. Okay. And we know we have this and this. I'm not sure what all this we're going to need. Okay, A, B, C, D. And I'm going to draw this diagonal in here. I'm going to draw this diagonal in here. All right. Now I'm going to separate this. So I'm going to take this triangle right here. That's triangle A, D, C, kind of this way. A, D, C. Now that had one mark down here and it had a mark over here. Okay, oh, sorry, got that out of the view of the camera. Okay, so you can kind of see where that one is. It's from this shaded triangle. It looks like this. And then I'm also going to do this triangle. Okay, so I'm going to do B, C, and A. I'm going to kind of draw that down here. Okay, B and C. And sorry, D, I think I said A. It's B and C and D. Okay, that also had a mark on it, and it had a mark here. Okay, now zoom out a little bit so you can see all this at the same time. Okay, so this triangle right here, A, D, and C, has this one mark from right here. Okay, and has this mark right here from this leg. B, C, and D, okay, B, C, and D has this mark right here, It has this mark on the leg right here. Now look at this. DC is congruent to DC. Reflexive property. It's the same exact segment. It's just this base right here. What do you notice? We have side, angle, side, congruent to side, angle, side. These triangles are congruent by side, angle, side. And if the triangles are congruent by side, angle, side, then that right there and that right there have to be congruent by what? Hopefully you remember CP/CTC, corresponding parts of congruent triangles are congruent. Look back up the picture. This is AC. AC is the diagonal. And BD, well, BD is the diagonal. So therefore the diagonals are congruent to each other. Right? So that we're going to write down. Diagonals are congruent to each other was letter B. Okay, so we're going to put that right here, letter B. And that is theorem 8.16 in your book. It says if a trapezoid is isosceles, then the diagonals are congruent. It actually has an if and only if, so it works both ways. If a trapezoid is isosceles, then its diagonals are congruent. If a trapezoid has congruent diagonals, then it is isosceles. Okay, so you can put it in if and only if form. A trapezoid is isosceles if and only if it has congruent diagonals. Okay. Now, going down to the very end part here, all right, E is still going to be true, okay, and G is still going to be true. If it works for a typical, kind of normal looking trapezoid, it's going to work for an isosceles trapezoid as well. So what were E and G? Come back here. Area equals height times base 1 plus base 2 over 2. We talked about that in the other video. And then the midsegment is parallel to the two bases and equals half their sum. We also talked about that in the other video. All right, so those still work. I'm not going to draw new examples of those. If you understood them in the previous video, you should understand them in this video as well. So, quick review of what we learned about isosceles trapezoids. A trapezoid with at least two congruent sides. A trapezoid, remember, had one set of parallel sides. So we have one set of parallel sides, which we call the bases, and the congruent sides are called the legs. You can get three congruent sides, both legs and one base. Okay, or it could be, you know, both legs and the bottom base. This one's a little bit too long, but it would work. Okay, A1 and B1 by definition means that we have one set of opposite parallel sides and one set of opposite congruent sides. we have two sets of consecutive supplementary angles and two sets of consecutive congruent angles. Looking back at the picture, make sure you understand which ones are which, okay? So the leg angles are supplementary, here and here. The base angles here and the base angles here are congruent. So, and if you look at it, it's pretty obvious. Obtuse and obtuse, they got to match up. Acute and acute, they got to match up. Acute and obtuse are not going to be the same, so they're going to add to equal 180. Same thing over here, all right? And then right here, our theorem for the diagonals says the diagonals are congruent to each other, right? I didn't even really talk about C and D, but they are not perpendicular to each other. And if I draw an example, let me show you that's why they aren't congruent, or why they aren't perpendicular to each other. So I'm going to draw kind of an exaggerated isosceles trapezoid, okay, like that. And you can tell that if I draw this diagonal in here and this diagonal in here, there is no way that this is forming a right angle. Excuse me. Also, do the diagonals bisect the angles? Well, if they did, this angle here would have to be congruent to that angle there, and that's not even close. Okay, so those other things for the diagonals do not work. And then finally, remember how to find your area, height times base 1 plus base 2 in parentheses and divide by 2. And then the midsegment theorem, which says that the midsegment, if you go from the middle of one leg to the middle of another leg, the opposite leg, then that midsegment is parallel to the bases and half their sum. That's it for isosceles trapezoids. We're going to come back with one more video for kites, and then we'll be done with lesson 8.5.